Diesel generators are often favored as reliable emergency power sources for several reasons. Firstly, their robust construction makes them suitable for heavy use. Diesel engines are known for their durability and ability to withstand demanding conditions. Secondly, fuel availability is a major advantage. Diesel fuel is widely accessible and generally less expensive compared to other fuel options. Thirdly, diesel generators typically have lower maintenance requirements compared to generators that use other fuel sources. Fourthly, they offer independent operation, meaning they can function independently of the power grid. This ensures a power supply even during grid outages. When considering standby power, there are specific categories to address: legally required standby power and optional standby power. Legally required standby power is crucial for powering essential systems like medical equipment and fire safety systems, which must comply with legal regulations. These generators need to be highly reliable and equipped with automatic transfer switches. Automatic transfer switches ensure a seamless transition to generator power during an outage. Optional standby power provides backup for non-essential systems such as refrigerators and lights. Although they don't need the same level of reliability as legally required systems, they should still be dependable enough to meet the intended purpose. Several factors can affect the reliability of diesel generators. Firstly, size and capacity play a role. Larger generators with higher capacities tend to be more reliable than smaller ones. Secondly, maintenance and inspection are crucial for optimal performance. Regular maintenance schedules should be followed, and thorough inspections should be conducted periodically. Thirdly, the quality of fuel use can impact generator reliability. Using high-quality diesel fuel ensures smooth operation and extends the generator's lifespan. Fourthly, environmental conditions can affect performance. Extreme weather, like extreme heat or cold, can impact a generator's output and efficiency. Fifthly, regular testing is recommended to identify and address potential issues before they escalate into major problems. Periodic load testing verifies that the generator can perform as expected under real-world conditions. Diesel generators are considered reliable for emergency power, particularly for legally required and optional standby applications. Their durability, fuel availability, and low maintenance needs make them a preferred choice for backup power. To maximize reliability, it's crucial to adhere to proper maintenance and operating practices. Regular inspections should include checking fluid levels, inspecting belts and hoses, and ensuring the battery is in good condition. Load bank testing is another important aspect of maintenance. Load bank testing simulates a power outage and ensures the generator can handle the required load. It helps identify any weaknesses or issues that may not be apparent during normal operation. Monitoring fuel levels is also critical. Adequate fuel supplies are essential to ensure the generator can operate for the duration of an outage. Fuel storage tanks should be properly maintained to prevent contamination and degradation of the fuel. Furthermore, proper ventilation is necessary. Diesel generators produce exhaust fumes that must be safely vented away from occupied areas. Poor ventilation can lead to carbon monoxide buildup, which is a serious health hazard. Consider the automatic transfer switch. The automatic transfer switch is a vital component that automatically switches the load from the utility power to the generator during an outage. Regular inspections and testing of the automatic transfer switch are crucial to ensure it functions properly. The generator enclosure should be inspected to ensure it is free from damage and provides adequate protection from the elements. The enclosure helps to reduce noise and protect the generator from weather-related damage. Also consider the cooling system. Diesel generators generate heat during operation, and the cooling system is essential to prevent overheating. Regular inspections of the cooling system, including the radiator and coolant levels, are necessary. Consider the lubrication system. Proper lubrication is essential to reduce friction and wear on engine components. Regular oil changes and filter replacements are crucial for maintaining the engine's health. The exhaust system should be routinely inspected for leaks or damage. Exhaust leaks can pose a safety hazard and reduce the generator's efficiency. The air intake system should be clean and free from obstructions. A clean air filter ensures proper airflow to the engine, which is necessary for efficient combustion. Battery maintenance is also critical. The battery provides the starting power for the generator. Regular testing and maintenance of the battery are essential to ensure reliable starting. Proper grounding is a safety requirement. The generator must be properly grounded to prevent electrical shock hazards. The control panel should be inspected to ensure all controls and indicators are functioning correctly. The control panel provides information about the generator's operating status and allows for manual control if needed. Finally, keep records of all maintenance and testing activities. Accurate records help track the generator's performance and identify any recurring issues. By adhering to these maintenance practices, the reliability of diesel generators can be maximized, ensuring a dependable emergency power source for legally required and optional standby applications. In addition to regular maintenance, several operational considerations can further enhance the reliability of diesel generators. Firstly, proper sizing is essential. The generator should be sized appropriately to meet the anticipated load requirements. Overloading the generator can lead to overheating and premature failure. Secondly, consider load management. Prioritize essential loads and shed non-essential loads during an outage to reduce the demand on the generator. Thirdly, conduct regular training for personnel responsible for operating and maintaining the generator. Proper training ensures they are familiar with the generator's operation and maintenance procedures. Fourthly, create a comprehensive emergency response plan. The plan should outline the steps to take in the event of a power outage, including starting the generator and transferring the load. Fifthly, consider remote monitoring. Remote monitoring systems can provide real-time information about the generator's operating status, allowing for proactive maintenance and troubleshooting. Sixthly, fuel storage considerations are important. Store diesel fuel in a clean, dry, and secure location. Regularly inspect fuel storage tanks for leaks or damage. Seventhly, noise reduction measures can be implemented to minimize noise pollution. These measures can include sound enclosures and mufflers. Eighthly, consider vibration isolation. Vibration isolation mounts can reduce vibration and noise transmission. Ninthly, surge protection devices can protect the generator from voltage spikes and surges. Tenthly, automatic voltage regulators can maintain a stable voltage output, protecting sensitive electronic equipment. 11thly, consider paralleling generators. Paralleling multiple generators can provide increased capacity and redundancy. 12thly, consider uninterruptible power supplies in conjunction with generators. Uninterruptible power supplies provide a seamless transition to generator power during an outage, preventing any interruption of critical loads. 13thly, automatic start-up systems can automatically start the generator when a power outage is detected. 14thly, consider automatic shutdown systems. Automatic shutdown systems can automatically shut down the generator in the event of a fault or alarm condition. 15thly, consider cold weather starting aids. Cold weather starting aids can ensure reliable starting in cold climates. 16thly, consider altitude derating. Generators may need to be derated at higher altitudes due to the thinner air. 17thly, consider fuel polishing systems. Fuel polishing systems can remove contaminants from the fuel, ensuring clean and efficient operation. 18thly, consider emission control systems. Emission control systems can reduce emissions from the generator, complying with environmental regulations. 19thly, consider using synthetic lubricants. Synthetic lubricants can provide improved performance and extended engine life. 20thly, consider fuel additives. Fuel additives can improve fuel stability and prevent fuel degradation. By implementing these operational considerations, the reliability and performance of diesel generators can be further enhanced, ensuring a dependable emergency power source. Diesel generators, known for their robust construction and fuel efficiency, play a critical role in ensuring power continuity during emergencies and plant outages. Understanding the intricacies of these systems, from their fundamental operation to advanced maintenance practices, is essential for maximizing their reliability and lifespan. The core of a diesel generator is the diesel engine, which converts chemical energy from diesel fuel into mechanical energy. This mechanical energy then drives an alternator, which converts it into electrical energy. The electrical energy is then supplied to the load through a distribution system. The engine's efficiency is heavily influenced by factors such as fuel quality, air intake, and combustion efficiency. Regular maintenance, including air filter replacements and fuel injector cleaning, is paramount to maintaining optimal performance. The alternator is responsible for generating the electrical output. Its performance depends on the integrity of its windings, bearings, and cooling system. Over time, insulation can degrade, bearings can wear, and cooling systems can become clogged, leading to reduced efficiency and potential failure. Regular inspections and preventative maintenance, such as cleaning and lubrication, are crucial. The control system is the brain of the generator, monitoring various parameters such as voltage, current, frequency, and temperature. It also provides protection against overloads, short circuits, and other faults. Modern control systems often incorporate sophisticated monitoring and diagnostic capabilities, allowing for remote monitoring and troubleshooting. Understanding the control system's operation and diagnostic features is essential for effective maintenance and troubleshooting. The cooling system is vital for dissipating heat generated by the engine and alternator. Overheating can lead to catastrophic failures. Cooling systems typically consist of a radiator, fan, and coolant pump. Regular maintenance, including coolant level checks, radiator cleaning, and hose inspections, is essential. The lubrication system ensures that all moving parts are adequately lubricated, reducing friction and wear. Regular oil changes and filter replacements are critical for maintaining the engine's health. Using the correct type and viscosity of oil is also important. The exhaust system removes combustion gases from the engine. It typically consists of an exhaust manifold, muffler, and exhaust pipe. Exhaust leaks can pose a safety hazard and reduce the generator's efficiency. Regular inspections and repairs are necessary. The fuel system supplies diesel fuel to the engine. It typically consists of a fuel tank, fuel pump, fuel filter, and fuel injectors. Fuel contamination can lead to engine problems. Regular fuel filter replacements and fuel tank cleaning are essential. The starting system is responsible for cranking the engine and initiating combustion. It typically consists of a battery, starter motor, and solenoid. Battery maintenance is critical for reliable starting. Regular battery testing and charging are necessary. Proper grounding is essential for safety. It provides a path for fault currents to flow to ground, protecting personnel from electrical shock hazards. Regular grounding inspections and testing are necessary. Regular testing under load is crucial for verifying the generator's performance. Load testing simulates a power outage and ensures that the generator can handle the required load. It also helps identify any weaknesses or issues that may not be apparent during normal operation. Record keeping is essential for tracking maintenance activities and identifying potential problems. Accurate records help track the generator's performance and identify any recurring issues. Proper sizing of the generator is critical. The generator should be sized appropriately to meet the anticipated load requirement. Overloading the generator can lead to overheating and premature failure. Load management is important for reducing the demand on the generator. Prioritize essential loads and shed non-essential loads during an outage. Proper ventilation is necessary for dissipating heat and removing exhaust gases. Poor ventilation can lead to overheating and carbon monoxide buildup. Noise reduction measures can minimize noise pollution. Sound enclosures and mufflers can significantly reduce noise levels. Vibration isolation can reduce vibration and noise transmission. Vibration isolation mats can help isolate the generator from its surroundings. Surge protection can protect the generator from voltage spikes and surges. Surge protection devices can help protect sensitive electronic equipment. Automatic voltage regulation can maintain a stable voltage output. Automatic voltage regulators can ensure consistent power supply. Paralleling generators can provide increased capacity and redundancy. Paralleling multiple generators can increase reliability. Uninterruptible power supplies can provide a seamless transition to generator power during an outage. Uninterruptible power supplies can prevent any interruption of critical loads. Automatic start-up systems can automatically start the generator when a power outage is detected. Automatic start-up systems can ensure a rapid response to power outages. Automatic shutdown systems can automatically shut down the generator in the event of a fault or alarm condition. Automatic shutdown systems can prevent further damage to the generator. Cold weather starting aids can ensure reliable starting in cold climates. Cold weather starting aids can include block heaters and battery warmers. Altitude derating may be necessary at higher altitudes. Generators may need to be derated due to the thinner air. Fuel polishing systems can remove contaminants from the fuel. Fuel polishing systems can ensure clean and efficient operation. Emission control systems can reduce emissions from the generator. Emission control systems can help comply with environmental regulations. Synthetic lubricants can provide improved performance and extended engine life. Synthetic lubricants can reduce friction and wear. Fuel additives can improve fuel stability and prevent fuel degradation. Fuel additives can help prevent fuel gelling in cold weather. Regular training for personnel is essential. Proper training ensures that personnel are familiar with the generator's operation and maintenance procedures. A comprehensive emergency response plan is crucial. The plan should outline the steps to take in the event of a power outage. Remote monitoring systems can provide real-time information about the generator's operating status. Remote monitoring systems can allow for proactive maintenance and troubleshooting. Proper fuel storage is important. Store diesel fuel in a clean, dry, and secure location. Regular inspections of fuel storage tanks are necessary. By understanding these intricacies and implementing these best practices, you can maximize the reliability and lifespan of diesel generators, ensuring a dependable power source.